I'm just going to record this just in case Annabelle is not able to join us. So let's get going. All right. So let's go back to the start. So today we're going to be talking about section 2, limits of functions, and activity 1 is the limit of the function. So in the last week or so, we have been looking at functions of series and sequences. Now we're going to go in and look at the limits of our functions. So remember the limits of series and sequences, we were just looking at natural numbers. So when it is above 0 and positive, so 0 to infinity essentially. But now we're going to look at algebraic functions, okay? So some of these, so here are some examples up here. 1 over x, the root of x minus 2 over x squared plus 4, and g of x is equal to x minus 2 over x plus 1, okay? So for these, we're going to be concerned with not only the top right values in the graph, but we're also going to be concerned with all 4 quadrants of these graphs, okay? So these here are called algebraic functions, and this is one which can be generated by combinations of the algebraic operations alone, okay? So addition, subtraction, multiplication, addition, finding powers and taking roots, etc. All right. So let's look at these 2 graphs here. The one on the left is a sequence / series. So we'll notice that these have discrete points, and remember that these are not forming a continuous graph. Conversely, if we look at the one on the right, this is a continuous graph, except that the vertical asymptote of x equals 0, that is the only place where we are not continuous here. So let's annotate. Excellent. Oh, there we go. Here is Annabelle. Perfect. Hello, Annabelle. Are you able to hear us?
Yeah, I am.
Perfect. All right. Good to hear. Quinn's no microphone today, so it's just going to be me and you chatting. So if you have any questions.
Wait, I can talk.
Oh, Quinn's back. Excellent. So yeah, excellent. Nice to hear both your voices today. How are we doing so far?
Good.
Good.
Doing pretty good.
Good to hear. Okay. So Annabelle, just to kind of summarize, we've only been going for about a minute so far. But yeah, so for the last week, we've been doing limits of series and sequences. Okay, so we're only really concerned in the top right quadrant, like we are, if you look at the graph on your left here, we're only concerned with the positive values. Now that we're getting into limits of functions, we're going to be concerned with kind of like the whole graph, okay? So
All right.
the graph on the left, again, it's a sequence in a series where we have just discrete points here. And the graph on the right, we have a continuous graph, except that's a vertical asymptote right here. Okay, so if we look at the limit of the graph on the right, so we have discrete points here, and n is a set of the natural numbers. So I don't have like all the fancy e's and stuff like that and n's. So we're just gonna have to deal with that. And then on the right here, we have a continuous graph, except the vertical asymptote at x equals 0. So I'm going to draw, I'm going to attempt to draw here. I don't have a stylus or anything like that. So on the left here, if we have the limit as n approaches infinity, that's actually pretty good. What is our limit here for the graph on the left as we approach infinity? What are we getting closer and closer to?
0.
0.
0, yeah, excellent. Perfect. Right? Good, and we can do that with like a table of values like we've done before. We get a really, really, really large value of n. It's going to be close to 0, but not touching it. Good. Okay, so for the one on the right, so what is the limit of f of x? Oh boy. As x approaches infinity for the right. What is the limit as x approaches infinity on the, so right up here?
That also be 0.
That is also 0. Good. Now, what if we wanted to look at it? So this is what we've just done. We've looked at the right side of the graph. Now we're going to look at the left side of the graph as well. So what is the limit of f of x as x approaches negative infinity? So we're going to look at the left side over here. And as x is going further and further and further, what is it approaching still?
Still 0.
Still 0. Good. Okay. And for this particular, so we'll notice that this is true for both cases. On the bottom case, this is only true for functions because we are looking at the whole graph, not just where x is a set of the natural numbers. Okay.
All right.
Any
Sí.
questions so far?
No.
Perfect. All right. So one challenge with the Zoom is that my text things don't jump with the page. So I'm just going to go ahead and delete those. If you need me to give you a little bit extra time to write those notes down, just let me know and I will leave those up. Okay. So for functions, we're going to discuss additional limits as well, not just what's happening as x is approaching infinity or negative infinity. Okay, so again, we're going to focus on this graph up here, right over here. Okay, so my question to you two is, I'm just going to make a note here. So for additional functions, or for functions, sorry, we discuss additional limits, not just positive infinity and negative infinity. Okay, so I'll get this out of your way. So the question is, I'll do a little, what is the limit of f of x, so of the graph on the right, as x approaches 0? So let's take a look at this. Okay, so we're looking at this graph here. As x approaches 0, we'll start from the left here. So we're going to say limit of x approaches 0, negative. Okay, so that is saying that we are approaching from the left when we have a 0, negative. That means we're coming from this way. Limit of f of x is equal to what? What is occurring in this graph as we approach 0 from the negative side? What are we approaching if we continue? If we were to graph the values, what would we get closer and closer to?
Negative infinity.
Negative infinity. Good. I'm not going to put an 8 there. Sorry. So negative, a sideways 8 is what we want. There we go. Negative infinity. Perfect. Now, let's do that from the right. Okay, so what is the limit of f of x as x approaches 0, positive? So what is happening? What is the limit as we are approaching 0 from the right side now? What are we approaching?
Infinity?
Yeah, positive infinity. Good. Cool. So as we approach from the left, the graph is approaching negative infinity as we approach 0. Sorry. So as we approach 0, and on this graph, because we're concerned with the whole graph here, as we come from the left side, we're approaching negative infinity. As we approach from the right side, we're approaching positive infinity. Are these limits the same? Negative infinity and positive infinity. Those are not the same, right?
No.
So if we're ever looking at a function and we're approaching from both sides, so if we're approaching from the left side, approaching from the right side, and we don't have the same limit, we're going to say that the limit does not exist. Okay, that's where our Mean Girls reference comes from. The limit does not exist. Okay, if they're not approaching the same value from both sides, the limit does not exist. Okay. Exclamation marks. All right. Any questions about that so far?
No.
No? Perfect. How is the lesson so far? Kind of slow?
Good.
A little bit? No, it's good.
Good, yeah.
It's like pixelated text over here. I ordered, it's like one of those snake things for your phones. I think it's designed for like your bed. So you like attach it to your bed frame and then you can like watch videos from your phone that kind of suspends it there. So I got one on my table, and like have it hovering down so I can do the calculations by hand, but that does not come until tomorrow. So yeah. Anyways, we're all good there. Let's move on then. Okay. So when we are looking to find the limit of a function, when in general x is approaching a, like a number, not just infinity or negative infinity, we can do this a couple different ways. Okay, so first off, we can graph and view the graph. However, this is really only good when we know what the graph is. Okay, so remember those 6 graphs that we talked about in the pre-calculus unit? So y is equal to 1 over x, x squared, x cubed, absolute value of x, etc. But for some functions, we're not going to know the graph is, so this method is not going to work that well. So graph and view the graph, or this only works well for graphs that we know. Okay, so keep that into mind. It's not impossible, but it might just be challenging in some cases. Okay. Number 2, text. We can create a table of values and view the trend. This might be, this is going to be useful. We've kind of done this before. And then lastly, we're going to we can solve it algebraically, of course. Okay, so those are our three methods. I'm going to show you how to do number 2 right now. Okay. Now this is going to be for the function of what we just did. So the limit of 1 divided by x is equal to whatever, and then I'm going to draw as x approaches 0 positive. So if it's 0 positive, are we looking at how the function is behaving from the left side or from the right side?
From the right side?
Yeah, from the right side. Perfect. So think positive when you see the positive, right? So we know this from the last one, 1 over x, as x approaches 0 from the positive. We know it's going to be infinity from what we last did, but let's create an actual table of values here, okay? So we're gonna do x on the top, and then we'll do, we want to use values that will describe what is, or it will describe the function of the behavior as it's approaching 0. So we're going to want to test values that are close to 0 and are progressively getting closer and closer to 0 without touching it. So for x, we're going to do 1, 0.1, 0.001, and 0.0001. Okay, and then we are also going to do what f of x is equal at that point. So for when it's 1, 1 divided by 1 is 1. 1 divided by 0.1 is going to be 10. 1 divided by 0.001 is 100, and you can disregard these decimals here. And then lastly, we'll have 1,000 if we divide 1 by 0.001. Okay, so this is just explaining as it is getting closer and closer to 0, it's getting further, or it's approaching infinity faster and faster. Okay, we can do the same here for as x approaches from the negative side. So we'll do lim of 1 by x is equal to, and then we're going to do a table of values again. So as we come from the left side, it's going to be -1, -0.1, -0.01, and -0.0001. And again, disregard these decimals. When I space over too far, it gives a period. Okay, so that's our x. And again, we're going to do f of x underneath that. So when x is equal to -1, we get a -1 again. And then we get a -10 here. And you guys get the point here. And then we get -100 and -1,000. Okay. And again, this is just showing that as that graph approaches x, oops, as x approaches 0 negative, so from the left is equal to -infinity. Okay. Okay, and then this is going to bring us to the last strategy, is solving it algebraically. So we're going to have 2 steps to this. So step 1 is going to simplify the function. And then step 2, we're going to sub in x into f. of x. Now, this is only going to work in some cases. Okay, in some problems, you're not going to be able to simplify the function any further, and then you can't sub x into f of x. So for example, like this one up here, the limit of 1 divided by x, it's already as simplified as it could be. So we can't necessarily sub x into f of x as it approaches 0, because that will give us an undefined solution. So we just kind of have to be conscientious. Oh, I can never say that. Conscientious. Oh my gosh. We just have to be aware that these strategies are not going to work all the time. Okay. But we're going to kind of know what strategies we can use given the problems. Okay. So here are 3 strategies. The algebraically, this is going to be our quickest strategy, but again, sometimes that's not always going to work given the problem. Okay, cool. So let's go into our first example here. So given x squared minus x over x plus 4. Okay, so we cannot do direct substitution at this point, because if we were to sub in x is equal to -4 here, it will make our function undefined. Okay, so okay, so then another way, let's just go through our 3 strategies to solve this. So number 1 is going to be graphing. So just right off the top of our heads, do we know what this graph looks like?
No.
Yeah, right. So not necessarily a good option, right? And of course, we could do like a table of values and that kind of thing, but that would be time consuming to find the graph. So let's move on to strategy 2, where we have a table of values. So like we were doing, so first we want to find the limit of x squared, that's an exponent, by the way, minus 16 divided by x plus 4. So that's what we're going to do. We're looking for the limit of that as x approaches -4 from the positive side. Okay, so let's go ahead and do a table of values for that. So if we have the plus side here, remember we're approaching from the positive side. So if we're going to do a table of values for x, and we're getting closer and closer and closer to -4 from the right side, our table of values is going to be -3, -3.9, -3.99, -3.999. Okay, so as we get closer and closer to 4 is what we're going to be doing here. And then, like we just did before, we're going to find the f of x at this point. So as we solve this, if you sub in x is equal to -3, you will get -7. If you sub in x is equal to -3.9, you'll get -7.9. And I would encourage you guys to solve this and do the substitutions yourselves. So 3.99 will get -7.99. And then lastly, we will get -7.999. So looking at our table of values, as we approach -4 from the right hand side, what is the limit of this function, or the half of this function?
8 or
Yeah.
-8?
Yeah, perfect. So therefore, limit is equal to -8. Good. So now we're going to do the same thing, but we're going to approach -4 from the left-hand side. Lim of x squared minus 16 divided by x plus 4. And we're going to do a table of values. And we are approaching from the left-hand side now. So our values for x are going to be -5, -4.9, sorry, -4.1, -4.01, and -4.001. And then we're going to find f of x at these points. So when it is -5, we have a value of -9. When it's -4, we have a value of -8.1, -8.01, and -8.001. Okay. So as we look at that, so as x approaches -4 from the negative side, what does it look like we are approaching to?
-8.
Yeah, perfect. So therefore the limit is equal to -8. Do these limits match?
Yeah.
Yeah. So the limit exists. The limit is -8 for this case. We just solved that using our table of values. Now we will try solving this algebraically. Okay. Are you guys good if I delete this?
Yeah.
Yep.
Okay, perfect. Okay. So algebraically. Okay, so as we look at this function here, how might we be able to simplify this?
Differences or perfect squares on the top.
Yeah, perfect. That is a very good idea. Okay, so if we do that, we can simplify it to, so the limit, I'm just going to write the simplified form up here. It's just a little bit easier for me. So if we factor that, we can get x plus 4 and x minus 4. And that's going to be divided by x plus 4. Now that we have that, that looks a little bit more familiar. What can we do with that? These are in brackets. These guys
Like-
can cancel, right?
Mm-hmm.
Then we're going to be left with x minus 4. Now remember, as we were solving it algebraically, step 1 was to simplify the function. And then step 2 was to sub x into f of x, so what it is approaching. So in this case, we'll sub in -4 minus 4 is equal to -8. And just a note on solving it algebraically. This is the fastest method if it works. Does not work, however, when the limit is undefined and cannot be simplified. use method 1 or 2. All good there?
Yep.
Mhm.
Okay. Perfect. Perfect, perfect. All right. So let's go back onto the mouse. Cool. Okay. So solving this one algebraically, can we simplify this any further?
No.
That's kind of is what it is, right? So in this case where it is, we cannot simplify further. And then remember the second step of using the algebra is to sub in the value of x. So if we were to do that using algebra, this is undefined. So we have to use another strategy. Let's do a graph because this is one that we should know by now. Man, it's a lot easier drawing graphs on here than it is to like write limits and put in variables. All right, cool. So if we use a table like we did back here. Oh, I deleted it. That's a shame. Yeah, so you guys have it in your notes. So if we were to use a table, okay, there we go. We're on the right one. If you were to use a table of values and use x, well, I'll just write it down. So if we did limit lim of 1 over x as x approaches 0 positive. You guys remember what the limit of this one is?
Infinity.
Yeah, good. And limit of 1 over x. So as you said, infinity. And then the limit of 1 over x as x approaches 0 negative is equal to
Negative infinity.
negative infinity. And again, if you guys, well, you guys should refer to your table of values that you guys have created a few pages back for that. And then what did we say about the limits if they do not match?
Limit does not exist.
The limit does not exist. We need, I'm going to find like a meme, and then anytime that the limit doesn't exist, the next slide is going to be the limit does not exist, and it's going to be 80, right? Okay, so that is just so with this example, we're just trying to communicate that you're not always going to be able to use algebra to solve these limits, which is unfortunate because I would say that's probably my personal favorite. It's just short and sweet, and table of values is fine, but it takes time. So, and we're really good at simplifying and that kind of stuff, right? Yeah. All right, let's get on to our last problem. So, solution or strategy number 1, graphing. Do we know what the graph of this looks like? I don't. Maybe you guys are better graphers than I am. I don't know what this looks like. So let's not graph this one. We could do a table of values, but we're going to use algebra for this. So how are we going to simplify this? Okay, that's okay. So let's look at the numerator. Let's focus on the numerator here, okay? So the degree of this function is 3, so it's a cubed. And we have an 8 here. Can we get to 8 by cubing something?
2.
Yeah, perfect. So this situation here, we actually have a difference of cubes, which means a to the exponent 3. Is that better for exponents if I do it that way, or I think that makes more sense actually, right?
Yeah.
Okay.
Yeah.
So a to the exponent 3 minus b to the exponent 3 is equal to a minus b. I get a exponent 2 plus ab plus b exponent 2. So this is a different of cubes for here. So what is our a value?
X.
Yeah, perfect. So a is equal to x. And what is our b value?
2.
2. Perfect. So let's go ahead and rewrite this then. So as the limit as x approaches 2 of, I have x minus 2, right? So a cubed minus b cubed is equal to a minus b multiplied by a squared plus ab plus b squared. So a is x, b is 2, so we have x minus 2 bracket x squared plus 2x plus 2 squared. And that's going to be divided by x minus 2. Okay, so now that we've kind of simplified it further, our x minus 2's will cancel. And we'll be left with, so limit as x approaches 2 of x squared plus 2x plus 2 to the exponent 2. So 2 squared is 4. And now that we are further simplified, we're going to substitute x into f of x. So that's going to look like, so 2 squared plus 2 times 2 plus 4 plus 4. It's going to equal 4 plus 4 plus 4, which is equal to 12. So just to summarize that, therefore, those are my therefore dots, by the way. The limit as x approaches 2 of x cubed minus 8. You're like, holy crap, can you write any slower? I know, I feel the same. Over x minus 2 is equal to?
12.
Yay, 12. There, that is a box. Yeah, so that's about it. I think we have the assignment. Yeah, so assignment is page 26, questions 1 to 3 in your module workbook. That's
Can
okay.
you
You
post
guys
that
have yours?
online? I don't have mine with me.
Oh, that's
Do
gonna.
you like post a picture of it maybe?
Yeah, absolutely.
All right, thanks.
Yeah, and then I'll just email it to you, Annabelle. Quinn, do you have yours?
Yeah, I do.
You do? Okay, perfect. Yeah, so Annabelle is what I will do then. I will just, because you're away for the week, right?
Yeah, I have to quarantine.
Me too. Me too. Don't feel bad. Are you excited about it or not? I don't know how to feel myself.
I think it'll be fine. It's only a week.
Exactly.
I
Although
don't
it's
even
kinda,
count this week, really.
sorry?
I don't even count the one day this week.
I know,
Like
right?
the best time to have to quarantine.
Yes and no. I don't know. I was really excited. Like my cousins were coming in from Toronto this weekend coming
I
up.
guess.
So I was like, yeah, cool. I'll get some.
Oh no.
But like school wise.
School, yes, school wise, it is like we couldn't have had a better time than right now.
Yeah.
Life wise, not so much for myself, anyways, but hey, such is life. Right? Sorry, Quinn, did you have a question?
Nope.
No? How was
I'm
the
good.
lesson? Did it make sense?
Yeah.
Yeah, totally.
Yeah, okay.
I screen recorded my Zoom meetings. Do you want me to post the video onto Classroom in case someone wants to go look at it again?
I also I also recorded mine, so I could, I'll go ahead and share that, Annabelle.
Cool. Thanks.
Thank you for recording that. That's really kind. That's perfect.
No problem. I can't like take notes right now because my 6-year-old brother decided to make a paper crown out of the ones I had printed. So
Is it a nice crown, at least?
I guess by 6-year-old standards.
Yeah, that's funny. Cool. Well, yeah, so that's it for today's lesson. Mrs. Schellenberg is going to be teaching in class next week. So you guys are in, well, Quinn, you will be in really good hands. I'm almost like a little nervous to like come back and take the reins again. He'll be like, we want Miss Schellenberg.
No, we'll miss you.
Like, I'm sorry. I'm doing my best.
I already have her for half the day.
Oh, perfect. So
Seen her enough.
you've seen her enough, yeah. Yeah, so she is going to record all of her lessons and stuff like she does for her class. So she will post the lessons to the Google Classroom, or well, she'll send me the links and then I'm going to post to the Google Classroom. So Annabelle, keep your eyes out for that.
All right.
And yeah, other than that, we're just gonna, that's about it. I don't think we have any assessment coming up for this other than our module 2 test, but that is probably a couple weeks down the road still. So
Okay. Well, thank you so much for doing this.
oh yeah, no worries.
Thanks.
It was I this was my task for the day. I mean, like I have other things to do, but this is like, okay, cool, gonna go get a chat with people and interact. It's quite nice because my roommate's gone, so it's just like me and my cat right now. So it's like pretty quiet around here. So this is this is awesome. Thank you too for coming in at like 11:01. I'm like, are they coming? Am I gonna get like ghosted on Zoom? But
Honestly, my mom's at work today, so me and my sister have been babysitting, and I actually completely forgot about it till I got the email.
oh really? Annabelle, no. But yeah. Quinn, were you waiting long in like the host or in the lobby or anything?
No, it was literally like 30 seconds.
Okay.
Yeah, no, not very long.
Because yeah, 'cause I was just like looking at the Zoom and I'm just like, okay, And I was just kind of like playing around with it. I'm like, oh, look, somebody can join. I better let them in. So
Mhm.
Yeah. All right.
excellent. Well, thank you too.
Yeah. Well, thank you.
Yeah, thanks.
Yeah, anytime. If you have any questions or need help with anything else, just send me an email. I will be home and available all day for the next 2 weeks. So I would encourage you to ask questions so I'm not going crazy here.
All right.
Okay,
All right.
sounds good.
Okay, well, you two enjoy your day,
Okay.
and we'll talk to you throughout the next couple of weeks.
You as well.
See you.
All
Bye.
right, sounds good. All right, bye.
Bye.